Welcome back, ladies and gentlemen. Today we are jumping all the way around this triangles unit. Okay, as I mentioned before, so you'll notice we're jumping to 6.6 now. We're going to focus on three types of triangles: isosceles, equilateral, and right. And we're going to talk some more about the vocab that goes with it, which you've already learned a little bit of, and go into greater detail of what properties are associated with each type. Okay, so put on a happy face and let's rock and roll. Okay, an isosceles triangle is a triangle with at least two congruent sides. If it has exactly two congruent sides, then they are the legs of the triangle, and the non-congruent side is the base. So as mentioned before, our base is the one side that's by itself, okay, and these are called our legs of an isosceles triangle. Okay. We also refer to these two angles down here next to our base as the base angles. Okay, base angles, which we're going to find out has some really good stuff that goes along with it. And lastly, the angle opposite the base is called the vertex angle. Not as important, but you will hear me drop that every now and then. Vertex angle. Okay. So here we go. What are these base angles? What's special about them? Well, if two sides of a triangle are congruent, then the angles opposite of them are congruent. We talked recently about associating the smallest angle with the smallest side, the largest angle with the largest side. So this holds true as well. If AB, okay, is congruent to AC, that's what those dashed lines mean, then we know that angle B is congruent to angle C. So if this is, say, 70 degrees, this must also be 70 degrees. That's an example for you. Okay? So they are going to be congruent. All right? Now the converse also holds true. The converse, which is going way, 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 way back. All right? We talked about if-then statements earlier in the year. So conditional is if two sides of a triangle are congruent, then the angles opposite them are congruent. Our converse, we're taking those statements and we're flipping them. Now they're telling us, if I start off by telling you those two angles are the same, you can then tell me that AB is congruent to AC. All right, so it works in both ways. If you have one, you can get the other. Okay. We also have a corollary to these two theorems, which is basically like an extension and add-on. And these are really kind of simple here. I think you guys are cool with this. If a triangle is equilateral, then it is equiangular. And if a triangle is equiangular, then it's equilateral. Basically, if all three sides are the same, looks like the flux capacitor right there. Bonus points for anybody that can raise your hand right now and tell me what the flux capacitor is from, because I'm not even kidding about that. Think about it, all right? But then, if those three sides are the same, those three angles are the same. Okay, cool. Lastly, all right, this we're going to get back to. I'm going to show this to you now. We're going to learn some congruence theorem soon. We're not really there yet, okay? And basically what a congruence theorem is it allows you to tell me two triangles are congruent based off of a set amount of information. So this is a weird one. It's called the hypotenuse leg. So if you have a hypotenuse of two triangles congruent and a leg congruent of two right triangles, sorry, it has to be a right triangle, must be a right triangle, then you are allowed to say that these two triangles, triangle ABC, boom, 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 is congruent to DEF, boom, boom, boom. The important thing when you write a congruence theorem, which I will go into greater detail later with, is you want to go in the correct order. A, B, C, so top, down, over, top, down, over, top, down, over, DEF, all right? What that allows you to do then is say angle A is congruent to angle D. Angle B is congruent to angle E, C to F, so on and so forth. Okay? Wonderful. Now we're getting the meaty stuff. Okay? So here we go. Let's see here. Can I zoom in a little bit? Nope, can't. All right. Here I have an isosceles triangle because I have these two sides the same. All right, so ladies and gentlemen, if these two sides are the same, I know that these two angles are the same. Okay? So what I can do is I can say 3x equals 63 because of the isosceles triangle. If I divide both sides by 3, x equals 21. All right, and we found our value of x. Now some of you might be thinking, hey, Mr. Howard, we just talked for the past couple weeks about what the three angles of a triangle add up to. Well, if you want, you could do 2x plus 12 plus 3x plus 63 and make that equal to 180. You don't have to do this, okay? This is extra. 2x and 3x is 5x, 12 and 63 is 75, all right, which equals 180. 5x equals 105. Sure enough, if you divide, you get 21. So don't think you have to do twice, right? But it will help us over here. You can't do this, all right? Can't do this for this one. Why? Because I have an x and I have a y. So you have to know if two sides are the same, those two angles are the same. So 5x equals 75. Okay, base angles is what we're doing here. Base angles. Now, if I divide by 5, x equals 15. Okay, well, I know it says solve for value of x, but you should also put in here and y. All right, this is actually almost a test question for you guys. If you plug this back in, I know it's going to be shocking, but it will equal 75 degrees. Okay, we need that because now I know the three angles of a triangle add to 180. So I can do 75 plus 75 plus 3y equals 180. Okay, just using triangle sum. 75 and 75 is 150. Subtract 150 over. Okay, divide y equals 10. So this is a very good problem and definitely one you'll see again, okay? You might possibly see that again, I don't know. Definitely a possibility of that. I don't really know what that means. Cool. All right, these are more puzzle problems and I just like to show this to you just because I think they're kind of neat. So I got a triangle here. Actually, strangely enough, how many triangles do you guys see here? Okay, you definitely have one, definitely have two. But if you open your eyes and you see they both together form a big triangle. So you actually have three here. Just interesting enough. These sides are the same, therefore the base angles are going to be the same. 70 and 70. All right, triangle sum. If I know two angles of a triangle, I can find a third. 70 plus 70, 140. I can do 180 minus 140, and I'll get 40 degrees up top here. Sweet, okay? Now, beside it, all right, hopefully you guys still remember this, a straight line always equals 180. So I can actually do 180 minus 70 and get 110. Cool. All right. Well, here's where we get tricky. I only know one angle of that triangle, but, okay, what I do know is these two sides are the same. Therefore, if this is y, this must also be y. Okay? So I've got a y plus a y plus a 110, and I'm going to make that equal 180. Okay? Y plus y is 2y. Please be careful, it's not y squared, equals 70. I can go ahead and divide by divide by 2. Y equals 35. That's a very nice problem. Definitely a lot going on there, but nothing that you guys can't handle. Okay. Cool. Over here, this is much the same. All right. You've got actually a lot going on here. Triangle to the left, isosceles. Triangle in the middle, equilateral. Triangle to the right, isosceles. So, okay, we'll start to the far right. If this is the same and that's the same, the base angles are the same, 70 and 70. 70 plus 70 is 140. I'm just going to steal from over here. 180 minus 140 is 40, so I know x is 40 degrees. Sorry, I'm just stealing previous work. I'm lazy. Okay, if I have an equilateral triangle, all three angles got to be the same. So if I do 180 divided by 3, I get 60. That's a division symbol there before. Okay, I get yelled at. So this is 60 degrees, this is 60 degrees, this is 60 degrees. All right, here's a more advanced move, okay? Hold on tight, here we go. This is a straight line. 3 angles make that straight line. So I can add together 70 plus 60, get 130, and then do 180 minus 130 to get 50. Okay, ooh, I know it's like multi-step. Well, now, if these two sides are the same, that's y, this is y. So I can then do the same thing we did over here. Y plus 50 equals 180. Subtract 50 over, add together the y's, I get y equals 85. Okay? Cool. Alright, at this point, if you guys are listening to this video, you may gladly just stop, just come up, get your classwork, we're good. This is a bonus thing. I'm going to show this to you real quick. You do not need to know this. Okay? This is called a 2-column proof. This is way more advanced stuff, alright? I love proofs. You do not need to know it from my class, but I'm going to show it to you anyway. A 2-column proof is a statements column followed by a reasons column. So what you always start off with is you write down the given. RV is congruent to ST, angle RTV, and angle SVT are right angles. Okay, and the reason for that is given. So right now I know that this hypotenuse and that hypotenuse are the same. Now, because we know they're right angles, you are allowed to say that angle RTV is congruent to angle SVT because all right angles are congruent. Okay? That's an angles right there. Sweet. 3. Can you guys see how these two triangles overlap on this side TV? So, you are allowed to say that TV is congruent to TV because of something known as the reflexive property of congruence. Okay? So think about what we have now. You've got a hypotenuse the same, you've got a leg the same, and you've got a right triangle. We can then say that triangle RTV is congruent to triangle SVT by the theorem that we have on the front called hypotenuse leg HL theorem. You can write it out, hypotenuse leg, or you can just write out HL. You do not need to know this. Anybody in my class that is interested in going to college for math or for science, you will have much more difficult proofs than this in college, okay? And I have lots of information and side stuff I can help you out with if you would so like to. I just figured I'd share it with you because I don't want to hold you guys back from anything that maybe you'd be interested in, okay? It's basically you're giving me a statement and you're giving me a reason to back it up. It's like arguing, that's what you're doing, okay? So thank you for all you guys do. Keep up the good work. As always, good luck. We're all counting on you.